So we're now going to talk about how do we deal with independent samples and what do we do with those, okay? So we're going to look at independent samples now. So I'm going to go back to, whoops, cancel that. I'm going to go back to sharing my screen. And we're going to talk about the other one. We're going to go into our course, and we'll look at section 9.3, which is independent samples. So in the class notes, we're going to come down here to the Google Drive over section 9.3. Oh, hit the wrong one. Okay. And I'm at the wrong place. Okay, 9.3. Here we go. All right. So we're going to talk about how do we analyze independent samples for two means. Again, independent samples is where one sample's values will not affect any values in the other sample. Okay, so like housing prices in Flagstaff as opposed to housing prices in New York City, they wouldn't affect each other. If we're looking at gas prices in Arizona compared to gas prices in Iowa, there's really probably no effect on one over the other. There's not one value that would affect any specific value over here in the other sample. So that's what makes it independent, is that one value does not affect any of the values in the other sample. And so we're going to go ahead. This just talks about how you run it. It's kind of the same idea. We're going to go ahead and do an example of this and show you how this works. We'll see if we can finish this up today. So we want to know, does drinking alcohol raise a person's pulse rate? And we want to look to see if it does. So we're going to use that same data set we've been playing with, that pulse rate, but this time we're going to look at whether alcohol of anybody affects the pulse rate of somebody. All right. So again, I'm going to read this, and even though I've already read it in, I'm going to read it in again, just in case you needed to do that. You copy that, go into your studio, paste it in. And we are using the pulse rate one. So I go look over here at pulse rate. Pulse, where's pulse? Where'd pulse go? There it is. So now we've got, again, all these variables we're looking at. Each row is an individual. So this is the unit of observation is each row. And so we have, for the first person, their height is 170 centimeters. Their weight is 68 kilograms. Their age is 22 years. They happen to be male. They happen to smoke. They happen to drink alcohol. They happen to exercise moderately. They didn't run before we did this. And we had their pulse rate before and their pulse rate after. And we have what year we did this in. So we have all this information here that we're dealing with. And what I want to know is, does alcohol affect it? So if I look at this column, I also have people that didn't drink alcohol. So here's somebody who didn't drink alcohol. And I want to look at what their pulse rates are doing. And so I want to look at, does the alcohol, the fact that somebody drinks alcohol, does that actually affect what their pulse rate is? For simplicity, let's just look at the pulse rate before instead of the pulse rate after. And we're going to look at each individual. So does this person I'm dealing with right here, this one I just highlighted, does this person's pulse rate before affect anybody else's pulse rate in the other group? Will it affect this person's pulse rate?
No, it would not.
No, it would not, because this is a person, their pulse rate is whatever their pulse rate is, 65 beats per minute. This person's a different person. What that person's pulse rate's doing wouldn't affect this person's pulse rate. So this is independent because their values don't affect each other. Notice also we're looking at different units of observation. So we're dealing with this unit of observation, and this one we're not dealing with any kind of values of the same with them. So this being the case, this is an independent sample. All right, whoops, wrong page. It's hard to find my pages up here. Oh, there it is. Okay, it's way over here. All right. So what we want to do is, again, we want to go through the same thing. We're going to show all the steps. So my question for you again is, We want to consider a person's resting pulse rate before, and use a sample and pulse to determine if alcohol increases the resting pulse rate. All right. So my question for you is this a hypothesis test or confidence interval? So the reason I ask you these questions every single time is first off, it's very important to know which kind of test you're doing. So it's a very helpful thing to be working with, is to be able to deal with that and know, am I going to run a hypothesis test? Am I going to run a confidence interval? You have a test due on Monday, and in that test, there's going to be a part where I ask you, is this a hypothesis test, a confidence interval? What kind of analysis are you going to do? So I'm trying to help you to kind of get you to think about this. So how do is this confidence interval? Am I trying to estimate something, which would be a confidence interval, or am I trying to make a decision, which would be a hypothesis test?
A hypothesis test.
Yeah, because I'm trying to make a decision. I want to know if the pulse rate before, if alcohol increases the resting pulse rate. So it looks like, just from this statement right here, it looks like all I want to do is make a decision. I don't know how much it increases. I just want to make this decision. So I'm making a decision, which makes it a confidence interval. I'm sorry, a hypothesis test. So this is a hypothesis test. All right, so I'm doing a hypothesis test. And so now my question is this one sample or two? Okay. So I got to figure that part out. Is this one sample or two? And we're going to be looking at whether alcohol affects the pulse rate before the exercise. So we want to know if pulse rate affects if alcohol affects your resting pulse rate. So what do you suppose I have to do to be able to answer that question? What do you suppose I would need to do?
Filter out all the other data.
Well, without looking at this data frame at the moment, without actually looking at what do I have to do physically to calculate this, just think about this in general. How would you answer the question of, does drinking alcohol, does a person drinking alcohol, is their pulse rate affected? What do you suppose I might need to do to answer that question?
Do the hypothesis test.
Okay, I need to do a hypothesis test, but I'm just talking even before that. What would I need to actually get to be able to answer that question?
Is there a mixture?
State the random variables.
Okay, without actually, we're not talking about doing the hypothesis test itself. I'm just asking you in general, before I do anything else, how could I actually figure out whether alcohol affects somebody's pulse rate? What would you want to know?
Their pulse rate before.
Pulse rate before? Of whom?
And after of the people. You'd need the information.
Okay, but I only care about whether alcohol affects their resting pulse rate. So what would I need to do? I mean, I realize we have a data frame, so you're all going to that data frame and thinking about what's in there, but I don't want you to think about that. I want you to think in general. If you want to answer this question, does drinking alcohol affect somebody's pulse rate? What would you want to do?
Take their pulse before they drank alcohol and after they drank alcohol.
Okay. All right, but this isn't looking at pulse, if the alcohol itself affects it. This is looking at if drinking alcohol in general affects it. So in other words, if I drink alcohol and you don't,
So
is my pulse rate different or increased over yours?
you'd need to know if they drank alcohol or not.
So I need to know if they drink alcohol or not, and then what would I want to do? So what would I have to do? If you want to know if alcohol affects something, what would you need? So why do we do all the stuff that we're doing? Can't seem to pull this up. How would you, if you were asked this question in general, without having any data in front of you, if you were asked this question, how would you answer it?
You'd say that you'd need the data.
So I'd need to collect data, right?
Yeah.
How would I collect the data?
Random sample?
Okay, so I'd take a random sample, but what would I do? What would I actually do once I have my randomness going? And Tammy, you actually said it. Or Tamia, sorry. I always say your name wrong, I apologize. So let's say I have 50 people standing in front of me. What am I gonna do?
Get their pulse rate,
Okay, and what else do I need to know?
if they drank or not.
Yeah, so I'd have to know if they drink and I'd have to find their pulse rate. So I'd actually have to go collect this data. I gave you the data, but you'd actually have to go collect this data. You'd actually have to do this. So how many variables, how many samples am I gonna have?
10.
Not 10. Hopefully not 10, because that would be really hard to do. We only have 1 or 2 samples that we're dealing with. Remember, the sample is different from the sample size. The number of values in there is different than how many samples you take. I take one sample that has 50 measurements in it.
Oh.
I might take another sample that has 100 measurements in it.
So it'd
So
be
what am I actually, how many am I actually taking in this case?
2.
Why 2?
Because you want to know before and after.
No, I'm not looking at before and after. I'm looking at resting pulse rate. But I am looking at 2. Why is there 2? So I want you to imagine that standing behind me are 100 people. And I'm going to measure all their pulse rates. And I'm also going to measure whether or not they drink. And let's say it's half drink and half don't. So I'm going to have 50 people standing over there that drink and 50 people standing over there that don't drink. How many samples do I have? I think you're overthinking this. I have 50 people standing over there and I measure their pulse rates and they don't drink. I have 50 people standing over here and I'm going to measure their pulse rates and they do drink. So how many samples do I have?
2.
I have 2. I have those 50 values over there of the people who don't drink, and those 50 values over there are the people who do drink. So there are actually 2 samples because I have 2 groups. And so you want to think of it as we have 2 groups. We have people who drink and people who don't drink. All right. Are they independent? Do any values in this sample over here affect any values over here?
No.
No, because the pulse rates over here are not going to affect anybody's pulse rates over here. They're different people. Why would they affect each other? So they're independent samples. All right, so now we know we have a hypothesis test. We know we're doing independent samples. All right, and we know we have 2 samples. Is this mean or proportion?
Mean?
Why is it mean?
Mm.
It's a proportion.
Why is it a proportion? Not to let you guys get away with just telling me what it is.
Jacob says because you're taking averages.
Yeah, I can't pull up my chat anymore because I'm taking, why am I, but how do I know I'm taking averages? I don't have the word average anywhere in here. What tells me that I'm using means?
The
I'll
percentage?
tell you what it is.
Oh,
What is a rate?
percent.
Rate's a percent?
Well, or I guess
If I measure my pulse, what am I doing? What am I gonna tell you?
something over something, or
No, have you not had your pulse ever taken? When they measure your pulse rate, what do they give you? Has nobody ever gone to a doctor and had them measure their pulse
Beats
rate?
per minute.
What was that?
beats per
per
minute?
minute.
Then more importantly than that, beats per minute, what do they give you?
Your pulse rate,
What is that?
number?
A number. The minute you have numbers, it's a mean. The minute you have numbers, it's a mean. Okay? So the minute you see that there's going to be numbers involved, you're going to have a mean. Proportions only come from counting individuals, counting something. This is not really counting. I mean, technically you're counting how many beats you have per minute, but it is not, you're actually going to get a number out of it. So that makes it means. So we now know we have an independent samples. We have 2 of them. We're doing a hypothesis test and we're dealing with means. Cool. So now we know all that. So now we can do our first step, which is to state our random variables. And the parameter. All right, so what did I measure? So my random variable is what I measure. You told me there's 2 samples, so I have to have 2 random variables. And what do I measure off of each unit of observation? So after those 50 people standing over there, what am I measuring?
Their pulse rate of the non-smokers,
Non-drinkers.
or yeah, drinkers. Sorry.
So I have the pulse rate of the non-drinkers. What's my second one then?
Pulse of the drinkers.
Okay. By the way, there's nothing that says that the first one is the non-drinkers, the second one's the drinkers. You could have done the other way. This is why it's kind of important to tell me which is which order, so I know. That's the only thing I would suggest, is that you do that. And then we've got our mean pulse rate of the non-drinkers and the mean pulse rate of the drinkers. And again, if you want to use the symbol, you can come over here to insert and insert an equation and go ahead and insert your Greek symbol. If you don't want to use the symbols, you don't have to, but if you want to, you can put them in. And then I would do the same thing here, insert my equation. And if you want to use Word, by the way, if you like Word over Google Docs, that does the same thing. It has an insert equations also. All right, so there's our variables. Now we get to our hypotheses. So again, we always have an HO and an HA. I always do the HA first because the HA is the question I'm asking. And what question am I asking?
If drinking affects their pulse rate.
Okay, so that would mean that the mean pulse rate of non-drinkers is, now I have increase here, but let's just go with difference, because I like your word better. So let's say if alcohol changes the resting pulse rate. So let's go with mean pulse rate of drinkers is different from the mean pulse rate of non-drinkers. Actually, I did the other way around. So we'll do drinkers here and non-drinkers first.
You're writing it under the mean.
Oh, I am.
Here.
Dang it. How did I do that? Okay. Mean pulse rate is different from the mean pulse rate of drinkers. Okay. And then what would HO be?
It's the same.
It's the same. All right, cool. So now we get to our third step of the hypothesis test. Again, all these steps are the same. They don't change depending on what you're analyzing. So you're still going to be stating and checking your assumptions. Now, what I want to mention is I said I had 50 people over here and 50 people over here. I don't have to have that. I could have 30 people over here and 75 people over here. Nothing says that the sample sizes have to be exactly the same. They can, in fact, be different, and it's okay if they're different. All right. So I don't need them to be exactly the same size, but I do need them both to be random samples. So because I have one group over here and one group over here, I'm going to actually deal with both of them individually different. So I would say a random sample of, and I don't know how many I have. So I can go into RStudio and look at my pulse rate, my pulse variable, but I don't really know how many I have that are alcohol and non-alcohol. I could tally them. So when do we do that? We're going to come down here and we're going to tally the alcohol of my data frame. This is pulse. I think this will work. And see what it does. Yeah. So now I know there's going to be 42 who don't drink and 68 that do drink. So notice they're not the same size. So I'm going to say over here in my thing that I have a random sample of 42 pulse rates of non-drinkers is taken. And separately, a random sample of, and how many did I say that was? What was the other one? Of 68. Of 68 pulse rates of drinkers is taken. So that again is where I state it. So I've just stated what I want to have happen. I don't know if that's actually what happens, but that's my stating. This is what I wanted to have happen. Now I can check it. And this is where I don't know. I have no idea how they took this data. I got this data off the internet. I don't know what they did with it. So I don't have an answer. So I don't know. So it is unknown what kind of samples were taken. So I can't answer that question, unfortunately. Now, the second assumption is a little strange assumption here. And that second assumption is that the samples are independent. So that's my stating it. My check would be what you already talked about. Do these people standing over here, these 48 people standing over here, one of those values affect any of the values over here in the 68 people?
No.
No. So I can say the values from the first sample do not affect any values in the second sample.
How do you know how many assumptions to write?
So each one, and this is actually, went through this really fast. I just said it's there. There are 3 assumptions for this test, and they're right here at the start. We have a random sample, we have the 2 samples independent, and then we have normal distribution.
Oh, okay.
Okay. So I was just going to do them down here, and I didn't actually give them to you. So now we can go ahead and do the last one. And that is that, again, what kind of populations we have, and we need normal distributions. So the population of all pulse rates of those who don't drink, we'll go with non-drinkers, of non-drinkers, is normally distributed. So then again is what we want to have happen. And then we have another population, the population of all pulse rates of drinkers is normally distributed. Okay. And how do I check that?
They're both over 30.
They're both over 30. but I still want to check that. I really want to go ahead and do the check of it. That's nice. The samples are actually okay. I mean, the t-test is okay if they're not normally distributed, if you got really large samples, but they really should be looked at first. So I
Okay,
do
so-
want you to check them first, and then we can say it's okay if they're not because we have large samples.
The histogram and the QQ line
Okay.
check.
So, but we only want to do it on the we want to do it on the pulse rate before because they're resting pulse rate. So we want to do a Q density plot. So GF density. And we want to do it on the pulse before. But we want to do it just for people who smoke, who drink, and those who don't. So remember, if you put that vertical line and then put in alcohol, that's the other variable we're dealing with. And then our data was pulse. It will actually separate it for that. Well, it's supposed to. Why didn't it do that? Huh. It didn't create it, but it's supposed to. That should have worked. Maybe I typed it wrong. GF density. Let's try pulse before. Tilde alcohol and see what that does. Nope, that won't work. Okay, I didn't think that would work. So that should have worked. So I'm gonna try it again just to see if this name was weird. There it goes. Now see, it didn't work this time. Okay, so there it worked. All right, so there it came in. I'm gonna go ahead and copy these so you can remember how to do that. We'll post that into our notes so you can remember how to do this check. And then I'm gonna go and get a copy of the graphs. Remember, we go to export over here in the plots. You go to export, say copy to clipboard, and then right click on this and do copy to image. If you're on a Mac, by the way, there is no right click, but if you do control click, it will do a right click and copy image. All right, so what do you think? Do these look normal?
Yeah.
Yeah. All right, let's go get the QQ norms. So GF, QQ. Again, we're dealing with pulse before. We want to separate it based on alcohol. And we have data is pulse. And we've got those, and they're going to export those. Copy to clipboard. And go put it in here. And I'll also put in the command I did so you can remember what command we did. All right. So what do you think? Do these look linear?
Yep.
All right. So then we can say the density plots are bell-shaped. And the normal quantile plot is linear. So the two samples appear to come from populations that are normally distributed. All right, and unfortunately we have 1 minute left of class, so we will not be able to finish this. And so we'll finish that one next time. We'll finish this up and then also do the confidence interval. show you how to go through those steps and how that works. And then we'll see how how this all fits together. Okay. I didn't write my HO and HA in symbol words. You can also write in symbols if you want to, because we have the means defined up here. So this would be an equal sign and this would be a not equal sign. All right, so we're pretty much out of time for the day. I do want to remind you, since I've got like half a minute of class, I want to remind you that there's a quiz or test. There's just a concept test for chapters 7, 8, and 9 that's in Canvas. So go into Canvas and take it. There are no calculations whatsoever on it. You will not need a calculator or are doing it. You're just gonna be answering these questions. And then there is the project that's also due. And if you want to start asking me questions about the project, you're more than welcome to, and help you out with those kind of ideas, okay? I've had one person kind of talk to me already, and then we can go from there, all right? All right, everybody cool? All right, I will see everybody next time on Monday of next week. You guys all have a great weekend.
Thank you, Kate. Have a good
Welcome.
weekend.
You too, bye-bye. Mike, are you good? Mikey?
I'm like trying to wrap my head around the whole thing. It's definitely kind of hard. I'm gonna go to Art's office hours after this.
Okay. Remember to also go back and look at these Google Docs, because that's why they're there. I fill them in as we go, and then they're all filled in. Okay.
I do. Yes, I definitely do that.
All right.
I was wondering if there was any way you could shed some light on number 4 for 7.3 or 5, whichever one.
7.3, 7.3 you're not doing.
Okay, on the online it says we just have to do 4, 5, and
So it says online to do 7.1 and 7.2, and then 7.3 it says don't do.
okay, cool.
Yes. So you're not doing 7.3 at all, because we're going to do those kind of in chapter 8 and 9.
Okay, cool. Yeah, it says 1, 2, 3, 6, 7 don't do. So I thought we would do 4
No,
and 5.
don't do any of them. Don't do the whole thing. I should have written that more clearly. You're not the only person who asked that.
Okay,
So you're not
perfect.
doing those at all. I'll
Cool,
rewrite it so that it's obvious.
Okay, cool. Thank you. And
You're
then
welcome.
for number 5 in 7.2, 2001, the Gallup poll one,
Uh-huh.
what would be your first like attack on that? Because I did 1 and 2 pretty well, and then 4 and 5 are giving me troubles.
Well, let me look it up because I don't remember exactly what they were. So let me pull up 7.7's homework.
And then if you need to go, I can also
Nope.
just ask Art too.
We're good. We're good.
Cool. Thank you.
We're good. So number 5, and 7.2. That's right. 7.2. You said number 5, right?
Yes, ma'am. The President Kennedy one.
Okay, so the President Kennedy one found that 81% of American adults believe that there was a conspiracy in the death. The Gallup poll asked 1,039 American adults if they believed there was a conspiracy in the assassination, and found that 634 believed that there was a conspiracy.
Mm-hmm.
Do the data show that the proportion of Americans who believe in this conspiracy has changed? All right, so test at the 1% level. So first off, I'm going to ask you the same questions I've been asking every single time we do this. Is this a hypothesis test or a confidence interval?
This is a, we're not doing the mean, so it is a, I wrote it down. We're doing a hypothesis.
Right, because we're saying, do the data show? So anytime you see something like do the data show, you're being asked to make a decision, and that's a hypothesis test.
Cool.
All right, and so is this 1 sample or 2?
We have 2.
No, we have 1.
Actually, no. Sorry, we have 1. I'm looking at 4.
We only have 1 because they only asked so many people. They only did it 1 time, and they are looking back at something that's already happened in the past.
Okay.
All right, we only have 1. And then is this proportion or mean?
Proportion.
Yeah, for a couple reasons. One is we're counting, and the second is it says the word proportion in it.
Copy that. Okay.
Okay, so this is a hypothesis test. So we would have our first step is always to state your random variable and your parameter. So in this case, we're going to count how many people believe there is a conspiracy.
That would be our,
That'd be your variable.
yeah, so people who,
And then your parameter would be the proportion who believe that there's a conspiracy.
okay.
So these are just stating in words, just in those exact words I just said, just saying to people, hey, these are what my letters stand for.
Mhm.
We're going to use the letters. All right. And then the next thing we do is the hypothesis test. And I always do HO first. But I need to
Okay.
make sure I did something here.